everybody, I'm Professor Rad, and today we're going to talk about adding and subtracting fractions. So we're going to start out with a question. So let's say you find 7 nickels, and just a reminder, nickels are worth 5 cents each, and you find 4 dimes, and a dime's worth 10 cents each. So you find 7 nickels and 4 dimes while you're cleaning out your pockets before laundry, and let's say your roommate asks you, how much money did you find? So how would you respond? So think for a minute, like, how would you answer your roommate's question? So if we're going to answer the question, probably the most basic way would be to say well, I've got 11 coins, right? So I had 7 of one kind of coin and 4 of another kind of coin. So I get 11 coins. And that's certainly an answer. It tells my roommate how many coins I had, but it doesn't tell them, how much money I had. So if I have 11 pennies, that's a lot different from 11 quarters, which is different from 7 nickels and 4 dimes, right? So if I'm going to add together the amount of money that I have to bear that denomination of the money in that finding of the sum. So if I have 7 nickels, since each nickel's 5 cents, 7 times 5 is 35. And if I have 4 dimes, each dime is worth 10 cents, and 4 times 10 gets me that 40. So I can convert each of those coins into how many cents they're worth, and then add them up and say to my roommate, I've got 75 cents. So if I'm going to be adding amounts of money together, I want to take each of those coin types and convert them into a common denomination so that I can add them, so that I'm adding the same thing. I'm not adding nickels and dimes, I'm adding cents with cents. This is because a coin is going to break up monetary value in the same way that fractions break up things into different sizes of pieces. And just like we need a common denomination of money when we go to add, we're going to need common denominators when we add fractions. We need to convert things into the same size piece. So if you want to pause and copy down this theorem, feel free to do so. But I'm just going to sort of summarize these steps here. So if we're going to add or subtract fractions, you either have a longer problem or a fairly short problem. So in the case of a fairly short problem, if your fractions have the same denominator, so if I had 7 nickels and 4 nickels, they would be the same type of thing. So I could just go ahead and add and say I have 11 nickels, which is 55 cents. So if you have the same denominator, you get to skip ahead and you add or subtract the numerators. So you add or subtract how many, but you keep the denominators, which we're going to treat kind of like a label, the same. If the denominator is not the same, then you have to convert each of those items into fractions that have the same denominator. And we've gone through a few of those steps in Chapter 5. Then you rewrite each fraction with the common denominator, and then you can add or subtract the amounts, keeping that new label, that new units. And then at the very end, you simplify your answer if it's possible. So in this video, we're going to do some of the shorter stepped problems. So we're going to add and subtract fractions that have the same denominator. And in the next video, we'll do some of the longer questions where they have different denominators. So let's get started with an example. Okay, so for this example, the very first problem we're going to solve is 5/9 plus 7/9. So you want to check to make sure your denominators are the same, which they are. So we're just going to add the top numbers. So 5 plus 7 is 12. And the sizes of our pieces were ninths, so we keep it ninths. Then at the end, you want to simplify your answer. In this case, because my numbers are fairly small and I recognize them from my multiplication tables, I'm going to use the repeated division technique, but you could use the GCF technique or the prime factorization technique to simplify if you prefer. So I know that 3 is going to go into both 12 and 9. So I'm going to divide the top by 3 and the bottom by 3. That will give me a 4 on top and a 3 below. I know 4 and 3 don't have anything in common, so that's going to be my answer. All right, let's go ahead and look at part B. So for this one, this time we're doing some subtraction, and we have 16/11 minus 5/11. Again, you want to make sure that the labels are the same, which they are. They're both 11ths. So that means we can just subtract across the top. 16 minus 5 is 11. And I keep that denominator the same. Keep the denominator 11ths. So now I have 11 over 11. And any number over itself is going to simplify to be just 1. So one of the things that I'm noticing about both of these examples that we've done so far, both parts A and part B, is that our final answer doesn't have the same units as the fractions we started with, and that's okay. So sometimes after you simplify, your units will be different. What's important is that when you go to add or to subtract, you have to have those same denominators at the start. All right, let's try part C. So here we have 6/5 minus 8/5. So our denominators are the same, so we've got 2/5. So we just subtract the tops. So now we have 6 minus 8. Now I'm writing this off on the side because I have a smaller number minus a bigger number. So I'm going to have to do a little bit of work to figure this out. You can think of this in terms of money, or in this case, I'm going to think about them in terms of shapes. So I have 6 positive squares, and I have, ordinarily I would have 8 positive squares, but the subtraction turns them to the other side. So I'm going to have 8 circles, which represent negative numbers. Then we've got a bunch of canceling going on, and we're left with 2 negative values in the end. So we end up with a -2 in the top, and we keep the 5 in the denominator. Now again, I use this method because these numbers were pretty small, and if I ever doubt my rules for addition or subtraction of signed numbers, I like to go back to the definition of what they are, just to be on the safe side. But if you'd rather use a rule, remember keep, change, change. So we keep 6, change, subtract to plus, and change 8 to negative. So we keep, change the operation, change the sign. Since the two have different signs, a positive and a negative, I'm going to subtract them. So 8 minus 6 is 2, and the 8 was bigger, so we get a -2. So one of the things to me that can make fractions kind of challenging is that under the guise of being these complicated objects in and of themselves, we have to go back and apply rules of signed numbers sometimes as well. So just take it one step at a time. And that's why, like I said, I liked writing this off on the side to kind of orient myself a little bit. Now, 2 and 5 are both prime numbers, so I'm going to leave my answer like this. -2/5, it doesn't simplify. All right, let's look at this last one. So this time we have 3 fractions, but we're going to work through it the same way as if we had 2. So each of these fractions has a common denominator of 15. So we're going to add and subtract across the top. And again, since this is a bigger question, let me just pull that off to the side. So the numerators are 3, 7, and then we subtract 5. So let's follow our order of operations. We're going to add or subtract from left to right. 7 plus 3 is 10. And 10 minus 5 is 5. So that means over here, I'm going to get 5 on the top and 15 on the bottom. Remember, the denominators are like our common denomination. So you could think of it sort of like if I said 3 cents plus 7 cents minus 5 cents is 5 cents, right? You wouldn't say 3 cents plus 7 cents minus 5 cents is cents, right? You wouldn't repeat the cents. So we don't change the denominator, it just stays like a label, just like the word cents would when we added our coins. Okay, now that I'm here at the end, I notice that both of these numbers are divisible by 5. So I'm going to divide the top by 5 and the bottom by 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. I have to keep a 1 if it's in the numerator. If it's in the denominator, we can scrap it, but if it's in the top, we have to keep it. So 3/15 plus 7/15 minus 5/15 is the same as 1/3. Okay, I wanted to make one last comment before we moved on. And one of those comments is when you are adding or subtracting fractions, you need common denominators. So even if your fractions that you're starting with are not in simplest form, it's okay if those denominators are the same. In other words, 3/15 could reduce to 1/5, and 5/15 could reduce to 1/3. But I don't want to start with that, because if I started with that, my fifths and 15ths and thirds would all have different labels. They'd all have different denominators. So with adding, the way that I like to think about addition is addition, you keep it unsimplified at the beginning. It's really messy at the beginning of an addition or subtraction problem. And then at the very end is when you simplify your answer. All right, so I have a few now you try problems that you can work out on your own. In the next video, we will do some addition and subtraction with fractions that have different denominators. So I hope you have a wonderful day, and I'll see you next time. Bye for now.